Hello everyone, this is grade 6, module 5, lesson 10 problem set. Question 1 says, how is the length of the side of a square related to its area and perimeter? The diagram below shows the first 4 squares stacked on top of each other with their upper left-hand corners lined up. The length of one side of the smallest square is 1 foot. So our diagram here, this is the first square. This is the second square, and so on. So they're all starting in that upper left-hand corner. And what we're trying to do now is with our chart, we're going to see what side length has an impact on the area and the perimeter. So the first thing I want to do is read my chart here. I got my side lengths here in feet, and I know that if one side is measured 1, then all the others are. The expression showing area, that's my length times width. This is my actual area. My expression showing perimeter, and the reason why we have 4 here is because there's 4 sides, and they're all the same for a square. So my expression really is 4s, which means 4 times the side. So whatever my side length is, that's the number that's going right there. They're just showing it as 1 times 4. So I'm going to do the same thing. I'm going to show it as side times 4. Just so we can match up where the 1 is. Like that 1 is the side length, so I'm going to put the side length first, and the 4 is going to stay the same as the second number, just to keep it consistent. And then my perimeter is right here. And you'll notice we have in feet and areas in square feet. So let's start filling this in. And I'll go part way through. So we have 2 as our length, so it's going to be 2 times 2. And that's 4, so that's my area, because that's length times width, and the length and width are the same. And then I'm going to put in my side length and multiply it by 4, because there's 4 sides. So now I'm finding perimeter. And remember, area is the amount of space on the inside, and perimeter is the distance around the outside. So that's why I shaded in for area and outlined for perimeter. And I know for perimeter, 2 times 4 is 8. So right now, the area is less than the perimeter. Let's see if that holds true all the way across. 3 times 3, and my area is 9 because now I'm on side length of 3. My side is 3, and I got to multiply it by 4 for 4 sides for perimeter, and I get 12. And it's still holding true, but I see that I was 4 away here from 4 to 8, and now I'm only 3 away. My next one, 4 times 4, that's 16. And then I have a 4 as a side length times 4 sides, and that gets 16. And now my area and perimeter are the same. So I'm going to put a star next to that one for my reference. That's where they're the exact same. Up here is where area is less. And then let's keep going. The next one, 5. So I'm going to do 5 times 5 for my area, and that's 25. And then I have 5 as my side length, and I'll multiply it by the 4 sides for my perimeter, which is 20. So now I have area is more. So we're seeing a shift there. So you can go ahead and finish the rest of this chart, but I'm going to go down through and do A, B, and C now because I read ahead a little bit. This chart's really important to see where it goes, especially when you get into N. And I'll do N real quick because that'll help out. So for this one, when the side length is N, or we don't know it, to find area, it's N times N, or n squared, we could say, because n to the second power means n times n. And that's really what this will be, is n squared. The expression for perimeter is n times 4, or 4 times n, depending on how you want to write it. And then it'll be 4n. So just at least we got that variable set in there, because we might need it down below. For B, in a square, which numerical value is greater, the area or the perimeter? Well, we're seeing that the area up here, when it's less than 4, a side length of less than 4, the perimeter is greater. When it's a side length of more than 4, it's the area. So that's what I'm going to put down for B. And there's my statement for A. When the side length is less than 4, the perimeter is greater. When the side length is greater than 4, the area is greater. So that's my statement for it. When is the numerical value, and I'm looking at C, when is the numerical value of the square's area in square units equal to its perimeter in square or in units? And we know that that's going to be the case right here. We talked about up at the top when it's less than 4 and when it's greater than 4. Well, what if it's exactly 4? That's when their values are equal. And there's my statement there, when the side length is 4. Now, why is this true? There's a couple reasons for it, and we can really look down at the last part that we filled in with n. And we're asking, why is it true that it's at 4 when the square's area and perimeter are equal? So it's based on C. Why is that the case? Because n times n is the same at 4 when we do n times 4. Meaning, this one right here, 4 times 4, that expression is the same as this expression. So when the expression for area and the expression for perimeter are the same, the area and perimeter are going to be the same. And the reason why it's at 4 is because this is a 4-sided shape. It's a square, so we're already given this 4. And we see it consistent all the way through. So in order for that to be the case, we have to have another 4 right here. And if that's the case, that's the side length of 4, we know we're doing 4 times 4 here. So we have n squared equals 4n, and we can see that. N squared equals 4n when the side length is equal to 4. When side length equals 4. Or we could even say when side length equals 4, or when n equals 4. And I'll put n in there just because that's what the side equals in terms of this chart. Let's take a look at page 2 real quick. So there's a couple things that we want to look at. I'm going to do question 2. With this one, it says, this drawing shows a school pool. The walkway around the pool needs special non-skid strips installed, but only at the edge of the pool and the outer edges of the walkway. A says, find the length of the non-skid strips that is needed for the job. So first I'm going to draw in where the strips are needed. It's going to go around the pool, just the outside. So each of those. And we see we have our dimensions there. And then it also needs to be around the outside of this space, the walkway. So now I can go in and I can actually start writing down the length of these strips. And I'll do it off to the side so you can see, and I'll do it in red since that's what we're looking at. So I need this one of 50, and the one across from it in 50, of 15 here, because that's this, and then this one as well, which is 15. And then I can look to the outsides. I have a 90 right here and a 90 up here. And then a 25 here and a 25 here. And we don't know how wide these are, but we don't need to know how wide these are because they're just strips. So what they just want to know length for this one. They don't want to know the area of it. So now we can add all of these up. And I see I have 10, 20, 10, and it looks like we're going to end up with our total of 360. And that's going to be meters because we're only looking at length here. So 360 meters of total length for this. Now B says the non-skid strips are sold in rolls of 50. How many rolls are needed? So if I have 360 meters I need, and I know that I have to buy them in 50 meter rolls, I have to see how many 50 meter rolls I can pull out of this. So I know that 7 times 50 is 350 because this is 50 or 5 tens, and 5 times 7 is 35. So if I subtract that out, I get a leftover. So really I need 7 rolls and 10 50ths, or 1/5. So 7 and 1/5 rolls. Well, I don't know if we can buy 1/5 of a roll. Probably not, because they're only sold in 50 meter rolls. So that means I have to round this up. So it's not 7 and 1/5 roll, it's 8 rolls, because I have to round that up. So I could have kept it as 7 and 1/5, which I did, or I could have added my decimal point and a 0 and brought that down and continued going into the decimal place. Your choice for that one. Thanks for watching, and good luck on your problem set.